Welcome. I think I'm your host today because Evold is on duty travel. But yeah, very exciting topic, and thanks everybody for coming. I'll quickly introduce the topic and welcome some guests from ETH Zurich and Ghent University. JF Baston, who welcome back, Jeff, and Tom Elliott from Crowther Lab. Welcome, Tom, and many colleagues from CB. Thanks for joining us. It's great. And yeah, basically the idea of today was to present some of the work we're doing in different parts of the forestry department and in collaboration with CB on and forest restoration monitoring. So we have a pretty packed agenda, but I really want to get through the presentation so we can have about half an hour of really nice discussion at the end, because I'm sure there'll be a lot of questions, particularly we're going to hear some of the latest science on this topic and some of the plans for the future from the scientific community. And I think within our mandate, we really want to see how we can help deliver some of this science to the countries. So please, in the last half an hour, we want to hear from the practitioners, the people that are actually doing restoration, and see what would help them do what they need to do. So we have a pretty packed agenda. Mette in a moment will introduce the UN Decade on Ecosystem Restoration and give us the big picture. And then we'll move to some of the technology innovation and some of the science with a series of presentations, which I'll have to be pretty harsh on the time to get through them. And then we hear a real practical presentation from the Forest and Landscape Restoration Mechanism. So this FTN is co-organized by the National Forest Monitoring Team, of which I'm the team leader of, and the Forest and Landscape Restoration Mechanism. And unfortunately, Christoph has another meeting, but Carolina is representing that group here today. And then, yeah, we have 30 minutes for questions and answers. So without further ado, I will hand the microphone over to our director, Miss Mette Wilkie, to give us the big picture. Does Mette need to sit here? Would that be better? Does
No.
Mette need to sit here? Yes.
No,
It's okay.
that's okay. I think they have me on the screen over there.
Great.
Roberto is good at that.
Good morning, and welcome, and thanks from me
To all of you for being here this morning to this very exciting event that we have here. I'm very excited about it because I'm one of the leads of the UN Decade on Ecosystem Restoration. Now, what is this all about? This was a resolution made by the UN General Assembly on the 1st of March this year, dedicating a whole decade to ecosystem restoration, but not just to the restoration. It's actually on preventing and halting and reversing degradation and making increased awareness of the importance of restoration and supporting movements towards existing international and regional goals and targets. It doesn't specifically mention that we should restore 350 million hectares by 2030, which is the Bonn challenge. And the reason why it doesn't do that is that there may be a bigger target coming out of the discussions that I had next year under the Convention on Biological Diversity, because restoration is very much embedded also in that convention. And they're agreeing on new targets, new Aichi targets, the post-2020 targets next year. So we do have a lot of commitments by countries already to restore. We do have some progress on the ground, but much, much more is needed. The important thing about the UN Decade is that it's not limited to forest and landscape restoration, which is where the Bonn Challenge was originally coined. It is focusing at all ecosystems, from mountains to the deepest seas. And if you ask me how we're going to restore the seabed of the deepest seas, I think I'll decline to answer that one. But there are certain aspects that we can do certainly about that ecosystem as well. It's about making sure that we ensure that the habitats are there for the marine life that are living in those areas. So we have a big task for us ahead, and that's why we've set up a group, because FAO together with United Nations Environment Programme were asked to lead on the implementation of this decade. So here in FAO we have two focal points. It's Eduardo Mansour from the Land and Water Division and myself. And within UNEP we also have a couple of focal points, but the main person there is Tim Christoffersen. Eduardo, Tim, and me are all foresters by training, which limits our discussions a little bit, but we also have broader training as well. And we are making sure that we have good consultation and involvement also from the other ecosystems. So we had a couple of weeks ago, we had a good consultation here with a couple of consultants that were helping to develop a strategy and a communication strategy for the decade. So they were here and met with a number of people. We had a big meeting on sort of brainstorming, but they also met with individual people and with different groups. As part of that, we asked people to sign up. Are you interested in this topic? Do you want to be on one of the two task forces that FAO is leading? One on monitoring, where we have Yoshihiko and Khalil that are the leads for that aspect. The other one is on best practices, where Christophe, who's not here today, and Vera from CBL are the focal points for that as well. So if any of you want to be involved in those task forces, and particularly since we're here talking about monitoring, talk to Khalil and Yoshihiko and they will put you on the list. That's probably the easiest way of doing that. We will take what is being discussed here, use that. We will have an expert consultation or meeting next year to see how we move forward on that. There are other initiatives out there to do monitoring. There's the Bonn Barometer. There's a meeting in Bonn very recently as well on monitoring progress towards the New York Declaration on Forest. And we need to make sure that we reach out and see how do we monitor restoration achievements also in the other ecosystems. So it's a huge challenge, and we have a year to at least set up a framework whereby we can use that to report back on progress. Because it is a decade of action. We want to see things happening on the ground. This is not about just meetings and events and awareness raising. We actually want to see action, and we want to see action by every single citizen on this planet Earth. Everybody can be involved in restoration. You can plant some trees in your back garden. You can go and pick up trash on the beach or in the forest. It can be everything from a very small scale, clean up the village pond, to a very large scale restoration in drylands as we're doing under the Great Green Walls or other areas. It ranges from restoring the agricultural productivity of land to ecological restoration. So the span of restoration is very broad as well, which makes monitoring very tough. And how do we actually make sure that we also monitor all these little activities? Clearly, we can't monitor them all, but we can make them visible by having a website where everybody can put up pictures and story about what they have been doing, and through that, getting a little bit of visibility at least. But we do need to have a proper monitoring system in place to monitor the big achievements, because a large number of countries have made pledges. Some of them have done a lot of homework to do that. Some of them have picked a number, and they're sticking to it. And as we will hear, in some cases, there's much more of a potential in those countries. In other cases, they will never reach that amount because the land is just not suitable. So, at least for planting trees. So, if that's the pledge that they had. But there are a number of pledges out there. Our task is to have a look at how realistic they are, help countries find out where can they do what, and what kind of restoration should they then embark on. So I think we've certainly got our work cut out. Delighted that there are some additional guests here to help us look at what we can do in terms of the monitoring aspect. But as I said, open call to anybody who wants to be on the task force on monitoring, Khalil, Yoshihiko, on the best practices, Christophe Bessachier, or Vera Berger in the CPL. Thank you.
Thanks so much, Mette. So I think we're talking about the right topic at the right time, given that we're on the brink of the new decade on ecosystem restoration, and it sounds like we have a lot of work to do. So yes, linking the science to the practice to the countries, and I think we have the right group of people here looking around the room, to the scientific community, different technical experts from the monitoring, and then the practitioners. So I'll just give a quick 5-minute presentation from my side, the forest monitoring side. It was 3 years ago we did a bit of a brainstorming in the team, and we realized that monitoring of restoration was really lagging behind the other monitoring efforts, particularly for deforestation, with many countries having systems and reporting for the losses, but really struggling with the gains. So we're very fortunate to work with Yoshihiko's ministry and articulate a new project with Japanese funding to really focus on this. I think to look at how we can look at first the mitigation potential of restoration and then try and support countries in measuring and reporting restoration. So the project, and Yoshihiko is our focal point with Khalil, is now in full swing, and I'll talk a bit about it, but that is the project under which we have the LOA with ETH, and under that LOA, our guests are here today as a part of a deliverable. So thank you. The second thing was on peatlands restoration. Many of you may or may not know that Indonesia currently underway is the world's biggest peatland restoration effort. And we're really delighted as FAO to be a part of this on the monitoring side. So we have two projects that are contributing to this in the NFM team. One is developing a specific peatland monitoring system for the Indonesian government, and Remy will give us some technical insights into that, based around CEPAL, and I'll talk a bit about that in a moment, and the Global Peatlands Initiative, which then allows us to take some of the work in Indonesia on restoration monitoring to the rest of the world through a great global partnership with UN Environment. So these three projects average about 2 million. We're running to the next biennium, so we're really interested also in brainstorming with you on how we can refine our focus and really make sure that we do the best we can and also contribute to the new decade. So Yoshihiko and Khalil, a better place to talk about this, but we designed the project with two phases. The first phase was to do an assessment of the global restoration potential, and I remember 18 months ago, I think Elena met with Jeff and Tom Crowther in the US, and you realized that you were actually going to do exactly the same thing. So it took a while, but we articulated a letter of agreement with ETH Zurich to try and bring some of this scientific results from your work to a forestry working paper, and then try and help get this science and innovation to the countries. So that's the LOA we designed with the Crowther Lab, and yeah, we weren't quite expecting the impact that you guys had with your scientific work in collaboration with CB and the forestry department. But yeah, it's we now hope, and we're working, and Khalil and Yoshihiko will talk about taking some of that work, delivering it to the countries, and in the form of a forestry working paper, and some modules that the countries can use to apply some of that machine learning techniques. The second bit of work that Remy will talk about is with Wageningen University, and that's trying to look at quite innovative ways to measure restoration success. So yeah, it's called BFAST, right, Remy? But it's dense time series, and it's been applied at the national level in several countries now with quite a bit of success. So trying to help countries measure when restoration is successful and then quantify that, particularly for reporting to the different conventions and things like the Bond Challenge. So I mean, our role, I think, is an exciting role, but really we really want to adapt the science and the global approaches and to the country context. So make them available to the countries and help the countries need to do what they need to do in terms of restoration. So yeah, the next steps for us is the Open Forest CEPAL module, where we want to have some really accessible tools for the countries to work out where to do restoration and then how to measure restoration. The forestry working paper that Khalil and Yoshihiko may talk about, and then also contributing in the house to the great work of FLRM, AAD, and generally toward the UN Decade on Ecosystem Restoration. So one really nice project we've been fortunate to have over the last year is the Peatlands Restoration Monitoring Project in Indonesia. Remy will talk about it, but in Indonesia they've been blocking canals and trying to do the world's largest peatland restoration effort. And we've been building systems in CEPAL to help them monitor whether this is successful or not. And we're super happy that CEPAL is the engine between two Indonesian government platforms. The first one is the Peatland Restoration Agency online portal, and the second one is the web portal of the Ministry of Environment and Forestry. And most importantly, CEPAL is providing the data on the soil moisture, and Remy will talk a bit about this, but it shows when they're blocking canals, the peatland is re-wetting, and they're actually achieving in some areas what they intended to achieve. In some areas, they're not achieving what they intended to achieve, but this is important for them to know. And we're super happy that particularly the ministry website, that link at the bottom, they did this more or less autonomously. And I think that's our end goal. When a government department can do this, they can use our platform and they can generate what they need to do for their own internal government purposes. Remy will talk about this, but all our technical work in NFM converges on the tools and platforms, Open Forest and CEPAL. Yeah, Remy will talk about this as well. But basically, the platform is in use by over 3,000 people in 160 countries. So all the modules we develop for restoration monitoring, for peatlands restoration monitoring, become accessible to a large community globally who can then use that to do what they need to do, both the government, the NGOs, the civil society. So I think that's enough from me. I will now pass to Jeff. This is the main event. Thank you, Jeff. Please.
All right. Thank you for the introduction. So it's I must say it's nice to be back within FAO. It's like a bit like going back home to work. So it's quite nice. I will start by saying that it was a nice experience for us at the Crowther Lab to do this collaboration with FAO, because as scientists often, like, we do our science in our corner, and here, like, we were directly collaborating with FAO in order to work on, like, the best way to try to bring that science to the country and to try to implement that science in the country. So it's quite nice to be able to touch that when we were developing our paper. So today I'm going to present to you briefly the main results of our paper, and I will also brush a bit the scientific debate that followed the paper, and then I will end a bit with some step about the follow-up work that we intend to do. So the work that we did was about the global tree restoration potential, and I need to start by reminding a bit from where it started, basically. So it started with a discussion that I had with Tom Crowther, which is the head of the lab in Zurich. And he published in 2015 a paper which made also a lot of noise, which was about estimating the number of trees that we have on the planet. And basically, this paper helped a lot restoration program, because at the time, most of those programs were aiming to try to restore 1 billion or a couple billion of trees here and there. But thanks to this estimation of Tom Crowther, we realized that if we want to have an impact on restoration and really like an impact on the climate, we need to be a bit more bold than aiming for 1 billion trees to be restored. So from that work, it shifted a bit the paradigm, and it pushed NGOs and international institutions to aim for 1 trillion trees to be restored. And as you can see on this very simple graph, like 1 trillion tree like really means a lot compared to what we have today. Like, this can really probably help a lot. But the thing is that this is all nice, but we don't know actually what the planet can support. So we don't know if that extra 1 trillion tree is even possible to reach, and we don't know if what we have today is basically already a bit outside the current carrying capacity of the planet, because the climate is changing. Climate is really like harsh in some regions of the world and already putting pressure on the forest. So we don't know, maybe we are already overshooting the carrying capacity of the planet, sorry. Maybe we can do a bit better than that 1 trillion tree, or maybe we can do a lot better. And so this is how we started, by trying to consider that we needed to try to estimate this global tree restoration potential of the planet and this global tree carrying capacity of the planet. So we try to answer that simple question: what is the limit of the planet in terms of capacity? So in order to do that, I don't know why everything is, sorry. Can I just go back? All right. Let's just, it's moving all by itself, sorry. So in order to do this, basically what we needed to do is that we needed to be able to understand, okay, what tree cover we can expect in any kind of environment. So considering like precipitation, temperature, soil type, topography, like what tree cover can we expect? So we needed to build a model based on observation of those tree cover under natural conditions related to precipitation, temperature, etc. So those are the orange dots that you can see on the graph here. And from that relationship, then we can build a model in order to extrapolate that relationship between natural tree cover and climate and soil data outside those natural environments. So in order to do that, we needed to have an observation of tree cover under natural conditions. So in order to do that, what we did is that we used collectors, which is a tool which has been developed within the forestry department of FAO in collaboration with Google, which allows to use like the very high spatial resolution images from Google to do photo interpretation and to really like count all the trees that we can intercept on the ground. This allowed us basically to describe the tree cover and a various range of tree cover in many different types of forest biomes. So in drylands, in temperate forest, in boreal forest, and in tropical forest. As you can see on this map here, what you have in all the yellow dots that you can see on the maps are basically all the points where we did this photo interpretation exercise. And all those yellow dots are falling into protected areas. This was our way to try to describe the tree cover under natural conditions. So we use those protected areas to basically approximate natural environments, basically. Then from that description, we related that to environmental data. So we related that to existing temperature data, precipitation data, edaphic condition, and topography. And we built a model. We built a machine learning model, which allowed basically to predict then the tree cover based on those environmental layers. And what you see here is basically the evaluation of the model. The two graphs that you see are basically the same, it's just a different representation of the data set. You have on the x-axis the predicted tree cover, so what the model predict, and on the y-axis the observed tree cover based on that photo interpretation exercise. What you can see is that well, it's not super clear, but the model fits quite well. The R-square is about 0.8. You can see also on the left graph that you have a line like on the diagonal, which is basically the line of the prediction of the model, so which is well aligned with what we call the 1-1 line here in statistics. And so the model fits quite well and is not biased, but of course, if you look at the graph on the right, which is exactly the same, it's just a different representation, you can see, for example, at the bottom line, you have the 0-10 here, and you go on the extreme right, and you can see that you have a couple of dots here around 100. That means that sometimes we predict 100% of tree cover where actually we have 0% of tree cover. So this means that at the global level, the model performs very well, but you might have at the local scale sometimes big differences with what is the reality. So this is a big challenge, especially when we work here with the FAO, when we try to implement like what we did at the global level, at the country level, we need basically to improve what we did at the global level to the local level. So based on the model, as I told you, we can then like extrapolate the prediction of the potential tree cover outside those protected regions. And this is the map that you can see here. So this is like a presentation of the planet if the entire planet will be a protected area, basically. This corresponds to, so you have the gradient of color that you have from yellow to blue is a gradient of tree cover, so yellow being close to 0 and blue being close to 100% of tree cover. If you convert this map into numbers, this represents about 8,700 million hectares of area that could present more than 10% of tree cover. So this is about twice as much as what we have today on the planet. And if you convert that into another metric, which we call canopy cover, so the canopy cover basically is the measure of the area covered by trees. So if you have 1% of tree cover on a pixel of 1 hectare, you have actually an area of 0.01 hectare, which is covered. And when you sum everything, you get the canopy cover. This is 4,400 million hectares. So this is all nice, but this is quite unrealistic because this is basically an entire planet under protected area, which is not possible if you want to live on a planet. So what we tried to do in order to get a realistic picture of what can be achieved through restoration is that we took that first map and we removed area where we know that we cannot do easily restoration. So we removed all area where we had croplands, all areas where we had urban settlements, and we also removed, of course, existing forest. And this is the result that you get. So this is actually the restoration potential. If you convert those into numbers, this represents about 1,600 million hectares that can be covered by more than 10% of tree cover. And this represents about 900 million hectares of canopy cover. So the other metric that I explained to you. Here I didn't really develop that in the slides, but because Julian mentioned it, this allowed us also to compare country by country the pledges of several countries to the Bone Challenge and what we saw. And it was striking to see that some countries are very far away from what they could do at the national level, even if we remove the croplands in urban areas. So some countries are really below 10% of what they could realistically do. And other countries are like far beyond 100% of the total potential that they have. So it was quite nice to see that by developing these tools, we can probably like better frame those pledges of those countries to the Bonn Challenge. So from that first part, that was really like the main part of the study, we were willing to convert those tree cover and canopy cover into carbon equivalent in order to know, okay, but what does that mean in terms of carbon sequestration? So what we had is that on a given landscape, we can increase the tree cover, and then we, at the biome level, like we know that we know the average carbon density that we have in a given forest, and so we scale that average density based on the percentage of tree cover that we increase. So if we increase on a given pixel 10% of tree cover, it's plus 10% of the average carbon density that we can have in those forests. And then we remove also the replaced carbon, in the sense that in some of those pixels where we do restoration, there was already a carbon maybe associated to a grassland or something like this. And so we need to, because this carbon is being replaced by the restoration effort that we are doing, we needed to remove it. So in the second phase, we subtract that carbon from soil and from existing vegetation, from the grid soil and IPCC maps. It's important to note here that the distribution, whoopsie, if I can stop here, all right? When in the paper, we use the trees as a proxy. What? I'm sorry. I don't know why it's going automatically. I did it now on a normal computer, but I don't know. It's fine. I will do it that way. It's fine. I will continue. So it's important to know that we use the trees as a proxy of the restoration of the whole ecosystem. So when we talk about restoration and carbon equivalent, we don't consider only the carbon that you have in the above ground biomass. It's the carbon that you have in the 5 pools of carbon. And it's important to know that according to the biome that you are going to restore, the distribution of the carbon will not be the same between the vegetation and the soil. So when you restore boreal ecosystem, you will have much more carbon in the soil than what you have in the forest. If you do that in tropical ecosystem, it will be the opposite. Now, doing that and extrapolating that at the global level, we estimate that between 133 and 276 gigaton of carbon could be stored through those restoration efforts, with the mid value of 205. And half of it is basically found in the vegetation and half of it is found in the soils. So now a bit about the scientific debate. I think that's one important thing that I would like to underline is that because we had a lot of criticism about the fact that we did not consider the albedo, we did not consider evapotranspiration, we did not consider a lot of things. Like the main question that we try to answer in that scientific study is what is the tree carrying capacity of the planet, and just translate that into carbon content. That's it. Like it's not an IPCC report where we try, to consider all the causes and consequences related to forests and climate change. It was one single question, and of course there are other many questions that we need to answer to, but each of those questions requires a specific paper. And for example, at the Crowther Lab, I know that several scientists are using that first step in order to better understand the feedback of restoration on evapotranspiration, on the albedo. And also I will develop further research with Douglas Schell, who did a comment on the paper on the impact on the water cycle. So this was the first step, and we will not consider those different steps in upcoming research. Another point that is important, I think, is that restoration is not mutually exclusive with conservation. So the thing is that, of course, like we need to conserve all the forests that we have, because if we cut, it's just like net emissions. And so we need to conserve that carbon in existing forests and in existing ecosystem. Restoration is not like a compensation to deforestation. Restoration has to be done as an additional part. It's a drawdown solution. So it's on one side, we need to cut emission, and so we need to conserve the forest. And on the other side, because this conservation will not be enough, and we need to draw the carbon down from the atmosphere, we need drawdown solution. And restoration here is probably one of the most effective solutions that we can develop in order to capture that carbon. Another point that I was willing to underline is that we had some comments from some colleagues working in savannas that were a bit afraid that because of our paper, like people will start to afforest in savanna. And I want to underline that here, this was not at all the aim of our paper. We tried to assess what's the optimal tree cover that we can observe in any part of the world. What's the optimal natural tree cover that we can observe? So here you have a map of the restoration potential only in those savanna biomes. You can see on the right, you have an histogram of the potential increased tree cover that we find in that biome. As you can see, the histogram is skewed on very low value. We have a median increase potential of plus 10%. So it's not about changing a savanna into a dense forest or eucalyptus. It's about just increasing a little bit the tree cover that you have over there. And not everywhere. You can see also there is a lot of yellow, which are increases of minus 5% of tree cover. So it's very, very like surgery. Like it's a very precise work that needs to be done. But with discussing with savanna ecologists, I think there is one point that we do not address in that paper and that I would like to address in the future is the fact that in some regions, if you want to conserve a given ecosystem, if you want to make it viable for several species, you need actually to sometimes to cut trees and to put some fires in savannas in order to maintain that ecosystem. Otherwise, you might lose like a very specific ecosystem, which is very good for several species. But the thing is that at the same point, normally, if you need to do that management on the land, this is not the natural structure of the vegetation. Like if you need like a regular every year management prescribed for your tree cutting activity, then this is not really a natural sustainable state of the ecosystem. So this was a bit the different point of view between like my work and the work of several of my colleagues. But I think that we can find, the idea is that there is not better solution. I think that in some cases, of course, we need to conserve those ecosystems. So we need probably to do this management, prescribed fires, because we cannot lose biodiversity. There is a lot of people which are relying on that also in local communities. But we cannot also avoid the fact that the natural structure of the vegetation could present much more trees and could store much more carbon. So the idea will be to try to take the best of both ends. And I'm actually developing now a research based on the work that we did. Is that for those who read it a bit in details, you know that we developed a map, an uncertainty map. So the idea was that we basically split our original data into several subcategories in order to generate several maps of restoration potential with different values. And we were able, like by superposing all the maps, we were able by pixel to calculate the standard deviation, so the variation of the prediction, basically. This gives us the uncertainty. But the thing is that you can see in some regions, the regions in yellow are the regions which are mostly, you have a lot in savanna system, in the Cerrado and in the Miombos in Africa and also in other parts of the world. But you have a lot of those yellow regions in those savanna regions. And basically my intention here is to try to see, by doing the same approach here, what would be the minimum tree cover that could be predicted and what would be the maximum tree cover that could be predicted. This could open a discussion about alternative stable state, and this could give the option to people to decide, okay, here we could have two different systems, and maybe if we want to preserve some hotspot of biodiversity, we could go on the savanna, grassland, but if we want to optimize the carbon, we can go on a more forested system. So the way forward, as I tried to explain, is that you saw that I talked about several improvements that we could do for our map, and we intend with the Crowther Lab to continue to publish regularly, a bit like Matt Hansen is doing, update of the map with like lower uncertainty and with more information that we can provide to the people on the field. Another challenge that we will try to tackle is to provide also more information at the local level. So for example, clearly, people implementing our map on the grounds, they want to have access to also information about what will be the forest composition that they should aim for. So the idea here will be to continue to work with Yoshihiko and Khalil and Julian to propose like methodology that could be implemented by the country and that could be customized by the countries, and maybe like to try to implement it within open forests. And then also, of course, it will be very important to try to downscale at the country level. So the resolution that we have originally is about 1 kilometer square, so it will be important to try to find solution in order to have a more precise final map that we can probably develop at the country scale if we get access to some country level information. So thank you. I think it's good for me.
Thanks so much, Jeff. We might just keep steaming on. Do we have Tom Crowther online? Oh, fantastic. To talk about some of the work that will be coming from the Crowther Lab. I think your paper has started a new research area. And it's really exciting to see what comes out over the next couple of years. So I think Tom Crowther is going to join us online to talk about some of his plans for the lab, building on this work. And also, I think Tom's a soil scientist, right? So I'm sure it'll have a soils focus. But maybe while we wait, is there any burning questions for Jeff? And you can ask anything. He assured me
Hello.
Hi, Tom. Welcome. Hi. Yeah, welcome. We're here in the Forestry Technical Network, and we'd love to hear about some of your. Jeff just presented his paper, and we'd love to hear about some of your plans in the context of restoration and restoration monitoring in the near future. So yeah, the floor's yours.
Okay. All right. Great. Well, thanks for having me. Sorry for all the technical issues. So yeah, I'll try and do a share screen if that works. So you can see a slide. Let me know if you can see this.
No, it's working perfectly.
Oh, okay, great.
Yeah. Not your presentation. Yes.
Wait a minute. Sorry. So I assume Jeff sort of left off with something like this. The restoration potential, which is obviously very exciting, and as we all know, it caused an incredible buzz and went all viral and got people talking about storing trees, which is great.
I think you can proceed, Tom. The presentation's not working, but you're a wonderful speaker, so you can speak to us.
Oh, okay. I've got a huge amount of feedback, so I can't really. It's kind of hard to talk, but I'll try anyway. So yeah, our next steps are sort of we're getting this understanding of about the tree restoration potential and the potential for restoring trees, but obviously restoration involves the whole ecosystem, not just the trees. And when you talk about the full carbon storage potential in most ecosystems, the soil represents probably the largest and most also highly variable carbon sink that has a huge potential for carbon sequestration. So we've been essentially building on the great idea that Jeff had to essentially take protected areas and to extrapolate those across the globe, but this time with the WOSIS soil data. So we've got about 600,000 soil sampling locations where people have sampled soil carbon. And again, by using the protected areas and modeling using covariates that don't have any human signal, we can generate a quantitative understanding of how much soil carbon there could be in any location across the globe. And the nice thing is, obviously, that isn't tied necessarily to the vegetation type. So it's just saying in any location, in any hectare, this is the amount of carbon that you could capture in that region. So it gives a sort of land managers a very simple baseline for what they can work towards. And of course, that spans hugely across the different vegetation types. So we found that there's actually room for about somewhere between 116 to 140. We haven't published it yet, so it's in that sort of range, gigatons of carbon that can potentially be sequestered in soil across the globe. And about, I think, 29% of that exists in forested regions. So again, that's restoring regions that are currently classified as forests. To their fullest potential, could capture 29% of that, whatever, let's say 120 gigatons of carbon in the world's soil. There's also about 39% of that would be sequestered in grasslands and shrublands. So not because those are the regions with the largest soil with the largest soil carbon stocks, but simply because they are the largest area on land that can be restored. There's about almost 40% of the world's soil carbon can be sequestered in those regions. And then possibly the most high priority regions are the wetlands and peatlands, where soil carbon, they cover less than 5% of the Earth's surface, but they can also capture about 31% of the Earth's soil carbon potential. So restoring those wetlands and peatlands represent a really high priority sort of focus. It's just 5% of the Earth's surface, and we can get a huge percentage of that 120 gigatons of carbon. So I think a big thrust of the research is now trying to expand beyond just forests to represent the whole ecosystem, and soil is the first step in doing that. But we've also got projects working on continuing down the forest line, because obviously, as we all know, forests don't just have a cooling impact through carbon sequestration, but they also impact the climate through evapotranspiration and through albedo, as well as a range of other mechanisms. And so we're essentially building on Jeff's initial paper to sort of predict what would be the change in albedo and evapotranspiration, and also cloud formation in all of those regions that you could restore across the globe, so that you can understand whether restoration will have a warming or a cooling impact around the world. And I think then that those are the projects that we're well developed on, and I think they're going to be finishing in the coming months or within the next year. But ultimately, we'd really like to now, the two areas that we're going to incrementally build into are both the financial side, so trying to work with economists to figure out the sort of financial value of any area of land in terms of agriculture. So there's a cool couple of projects that estimate how much that land could be available, could be worth if you were to grow the most productive crop on that land. And then that can help us to figure out, if you were going to be using that land for carbon credits and tree restoration, whether, what that value would have to be in order for it to be to be competing with the other land use types. So I think that's one direction that we're going to be expanding into, and that's a very early stage. And the other area is essentially to build this research platform that can allow users to have a much simpler user interface, so that they can now zoom in really to the scale of their garden and estimate all these things, see information about the soil and about the tree potential and about the climate warming impact. And then the very final thing that I think is really going to be a large area that we're going to expand on is our research into agricultural systems. Because as we know, in Jean-Francois's paper, we intentionally removed agriculture, and that sort of makes it a very conservative model, because there's room for trees within many agricultural systems. And what we're finding, and what a lot of research shows, is that trees actually can improve, or at least not limit, agricultural productivity up to a certain extent. We're working with someone who just did a study in West Africa with cocoa plantations, and she found that the optimum tree cover in cocoa plantations in West Africa is around about 30 to 40% tree cover, and that's to maximize agricultural yield. And what we'd like to do is start compiling more and more data on agricultural yields around the world, and by pairing that up with information about tree cover, we can then figure out what the optimum tree cover is in any region of the world for any different agricultural type. And I think that's going to be a really, really big research avenue for us in the coming years. So I hope that made sense.
No, that was
without
wonderful.
the slides.
That was wonderful. Thanks, Tom. Yeah, particularly the work on agriculture. Did you want to comment?
No one's there.
Oh, okay.
I can't hear you. Okay.
Okay, that was wonderful. Thanks, Tom. Yeah, particularly the work on the agriculture, and there's a lot of momentum in the department on agroforestry, and that would be wonderful to keep in touch with you on that particular research stream. But are there any quick questions while we've got Tom on the line? Because he may disappear, but Mette or anybody? No? Oh, Marieke, please, just push your button.
Yeah, thanks both for the presentation. I thought that was very interesting. No, I was just wondering, when you look at the tree planting potential at the country level, and you compare it with the commitments that countries have made through NDCs or other communications. I was wondering if it would be interesting to also look at FAO's has a team in the Global Perspective Studies Unit. So they actually project cropland up to 2030, 2050. So that would, I mean, you could say like, okay, it doesn't actually make sense now, but maybe, you know, the cropland would also change because in a lot of countries, like there's a lot of intensification. So you need less land to produce more. So I was wondering if that was, okay, there's probably a million things you could do. so maybe this is not something you really want to add at this stage, but you know, just
No, that sounds really good. I mean, honestly, any projections of future land use are going to be incredibly valuable as we build on these models. I think at the moment, we're still focusing on just the physical potential of the planet, and we're not taking into account those human decisions. But I think, given the amount of feedback and the amount of interest that Jeff's paper got, we have to seriously. I don't think we can do that for much longer. We need to start representing the future changes in land use very well, and so that products like that are going to be incredibly valuable. Although it's hard. I think the land use projections seem to me to be among the most uncertain of all the future projections, including climate. So we're working with an organization called Bula, who have their own. So they're a big industry producer within the agricultural sector. So if there's any machines that are needed to harvest or squash or process or produce food, most of the large agricultural organizations or food industry companies work with them, and they've got their own projections of land use, which actually suggest that they're going to see a drastic decline by 2050, a decline in the amount of land used for agriculture, but a doubling in the amount of productivity. So, I mean, I'm not saying they're right. I'm just saying that there's huge uncertainty in those ones, and it'd be great to work on finding a consensus for those future land use projections.
And if I can add something, I think that one of the key also is that we will not be able to cover all the question, but one thing that we need to do and to make sure is that what we produce, the map that we produce, are easily accessible to people like from that team that you mentioned, so that they can easily, for Yoshihiko, and the combination of the projection of land use and the map that we did for restoration can easily be done, so that anyone interested into doing that can do it. I think that there is more and more tools developed within FAO, within the forestry department, within the open forest, also within CB, where they try more and more like to make those tools available and those maps available. So I think that it's just about like putting the dots together and making the data available so that anyone can do it. I don't think that necessarily like we need to do like everything, but I think that we need to make sure that people can do it easily.
Thanks so much. I think that's a fantastic segue into Remy's quick presentation about some of the innovative work on the platform side. Remy, thanks so much, Tom. I hope you can stay with us, but we'll proceed with the next presentations.
Fantastic.
Thank you very much.
Thanks.
Yeah.
Thanks, Julian. I guess you've introduced me enough now, so everybody knows I'm Remy. So let's. Is that mine? Nah, it's not mine. Wait, shall I go through? Where do I start? Okay, there's that. That's fine. Wait. Yeah. So we'll try to do something interesting after these major slides and very interesting approaches. This is lower scale projects, and this is more let's say applied examples at the moment. Is that working? Yeah. But one of the tools we have developed within the Open Forest Initiative is the CEPAL, as Julian mentioned earlier. CEPAL is a cloud computing platform that gives us access to huge computing powers, and that has helped us accompany countries and support countries in using cloud-based processing for remote sensing in many different areas. And I'm going to touch base on a couple of the examples in which we have used Sepal, with trying to focus on restoration, obviously. Just to correct what Julian said before, we don't have 3,000, we have over 4,000 now as of last week. So registered and active users inside the platform. The platform is free, it's open, it's completely available at sepal.io. And if you have not registered to the platform, I really strongly advise you do so. We are representing over 85 countries and more than 225 organizations. More importantly, in the context of RED+, we have more than 70% of the existing reference levels that have used some of the tools inside the Open Forest tool suite, and a lot of them including Sepal to generate activity data, for instance. So, like I said, Sepal is open source. It's basically been designed in the first place to reduce time for trying things, basically reducing time for failing. So you can generate big objects, make them wrong, then realize they're wrong, and instead of spending a week waiting for your wrong objects to come in, you just wait for like 5 minutes to realize it's wrong and then start again. And by shortening those times, we've actually managed to get some success. So in the first place, we fail fast, and then we slowly but surely succeed. I'm not going to go into this, but we have plenty of tools. This was just to mention the open source tools that we have, or the public tools that we have, Google Earth Engine not being open source, but being public and free. But yeah, there we go. Where have we applied, or where have we used, or where are we planning to use Sepal? The National Forest Monitoring Team has many projects in the pipeline. So one of them is the Japanese funded project, and I guess you guys will talk about it afterwards. Yoshiko will talk about that. Yoshiko is in charge of this, focusing on 4 countries. The global map of tree cover potential has been extensively and already very well covered by Jeff and Tom, so that's fine. Some of the things that were mentioned during the presentation is try to go from the global approach to do this at national levels, and these are things that could be potentially implemented inside Sepal. All the code that have been used by Jeff and Tom are, if I'm not wrong, open source and available, and could perfectly be implemented inside Sepal. Actually, some of it has been. Yeah, to try to refine those models is something that we can do easily inside Sepal. And Sepal is a place where you can also share your codes and make them accessible to a wider range of people with all pre-requirements, installations, and so on done. So I guess, Yoshiko, you will talk about the restoration module. And just to mention, out of the paper, we have been studying here inside the department, but also maybe beyond. I'm not sure about that. On the setting up a working paper to make that a scientific paper more widely exposed and yeah, go beyond. So we're going to have a forestry working paper on the global forest restoration potential that will try to go just beyond the tree cover potential that was described in the scientific paper. So some of the results, for instance, of what we're doing to generate data for restoration and for actually monitoring existing restoration and gains. So in that case, we're talking about restoration of tree cover. This is an example in Uganda, where using dense time series of Landsat data, we have, you probably all know that all the archives of Landsat are the longest and densest existing remote sensing data available to work on time series and to work on dense availability of data since 1984, basically, that we have regular acquisitions of this, and every 2 weeks global coverage. And the fact that these data have been made available for around 10 years now, and that we have cloud computing platforms that enable to process the huge amounts of data that are beyond, made it possible to develop what we call dense time series analysis. And that allowed to take all observations into any pixel into account to make to look at the trajectory of each pixels and then be able to assess the changes that are happening, not looking at just 2 points in time, but looking at the full trajectory and the full profile of pixels. So that enables us to detect gains, for instance. Jesus, I didn't realize that it was like so we could not see that much. But basically here, if you were in front of the screen, you would see an empty space. You can't even see my mouth right now. Yeah. So this space here is empty on the Google image. It's been detected as gains. Oh, that's nice. And then a couple of years later, we find it. So we have developed these methods, and this is in collaboration with the University of Wageningen, where we are able to pick up changes, pick up gains, and where we do have restoration activities going on, we are able to monitor them. On a broader scale, so this is a zoom out of the same area. I think the area I showed you before is somewhere around here. This has been extensively used now by the Uganda National Forest Authority because they have set up protection and moratoriums on some of their protected areas. And we carried out a BFAS analysis, because that's how it's called. And we can very clearly show that we have losses showing in red or orange all around the zone, and also some gains outside, but that the zone inside has been completely untouched. And this is not a product that's been masked. This is the raw results from the changes that exactly align with the borders of their protected areas. And this has been used to show how strong the enforcement of the protection was being done by Ugandan authorities. So they were very happy to show some independent data showing that this is reality. Propaganda for the country, as our DG called it. So that's one use we make of dense time series, is to look at gains and losses and degradation and monitor those areas. Another thing we're doing is make use of the existing data provided by Copernicus mission, especially the radar data released since 2014 through Sentinel-1. And we also, in that case, have dense time series of imagery available, huge amount of data that needs to be processed. And we have set up inside CEPAL ways to make this radar data analysis ready. And this is an example of getting some of those radar clips over a part of Indonesia and turning it into soil moisture maps. Soil moisture is one of the indicator of peat and peatland status. And we've been using global models of climate and edaphic and environmental parameters, and align them with Sentinel-1 data to produce soil moisture maps, also using in situ soil moisture calibration. And both time series of vegetation, the thing you have behind, and soil moisture maps are being used as inputs inside the Peatland Restoration Agency of Indonesia and the Ministry of Forest and Environment also. So basically we have a workflow where the technicians from these ministries and agencies use CEPAL to produce data, and then they put those data inside the platforms and regularly update them. Quickly, just to mention 2 more slides. What we're doing at the moment in peatland restoration is we're focusing mostly on vegetation as a proxy for soil moisture, where we do have vegetation, because the radar data that is available through Sentinel-1 has got small wavelengths, so it doesn't really go through the canopy. But we have very good perspectives coming with the release of L-band data, and ALOS actually in Japan actually announced last week that they would release the integrality of their radar data. So we're going to have access to much more L-band, and L-band is a type of sensor that will go through the canopy and that will allow us to make these soil moisture maps and these soil moisture models go actually through, so we won't have to use just proxies, but we'll be able to detect soil moisture on a much wider place. And continuation with the USA program with NISAR coming in 2 years' time. Last thing, we've been using also the very high temporal and high cadence data that's just been released. We managed to procure data with Planet, and one of the target countries is Indonesia, and we're using this 3-meter daily data to look at all the subtle changes that are happening and to do validation for canal blocking, for instance, so to actually measure and to actually verify the restoration activities. Just to finalize, to go beyond just what we're doing in forest and peatland, we're also using CEPAL to generate detailed biomass maps and vegetation maps and degradation maps in the context of protracted crisis around refugee camps to assess fieldwood resources. And we have a series of papers and documents that are touching base on this. We also have examples of using dense time series for forest road closure, for instance. So whenever we've had like really good examples lately in Congo and DRC, where we can actually use BFAST to quickly pick up those gains in certain ways. And finally, CEPAL is a collaborative platform that is working in collaboration with many donors, agencies, universities, and we are in the process of upgrading our dense time series analysis, and we're going to go beyond BFAST, and we'll slowly shifting to other algorithms that will provide very interesting transitions between land cover and land uses, and that might prove helpful to follow up on what Jeff and Tom presented. So that was a quick snapshot of what we're doing in CEPAL, and happy to talk about that.
Thanks, Remy. We're running a little bit behind, but now transitioning to some really more practical work from Carolina and the work of FLRM, who work in the countries at project scale to do actual restoration. So it's good to put our feet on the ground, and I hand it over to Carolina. Thank you.
Thank you, Julian. I'm just going to very quickly present the publication that we've been working on with WRI. That is called the Road to Restoration, a guide to identifying priorities and indicators for monitoring forest and landscape restoration, which is a very flexible guide that we have created just to help people working on restoration activities design a comprehensive monitoring system and to make informed decisions and measure their progress. So just to give a bit of a background for people that haven't followed the process, this work started already in 2016, right after the Drylands and FLR Monitoring Week, during which participants endorsed a collaborative roadmap for FLR monitoring that encouraged and supported countries and in-country actors to develop and to monitor FLR at all scales. So I'm not going to get into detail into all of the activity streams, but the first activity stream was specifically the development of a guidance document to help monitoring. So from 2016 till now, we had many different iterations, lots of consultations with many partners from different organizations, including also many colleagues from FAO, both at headquarters and the regional and national offices, and also some field tests in El Salvador, Ethiopia, Kenya, and Malawi. And finally, we have finished the publication. I haven't brought any copies, and it's not available online yet because we're launching it officially on Friday at the annual GPFLR meeting that is happening in Luxembourg, back-to-back with the GLF. So the guide helps creating a system that can be tailored to each specific context for specific objectives, and also including both biophysical and socioeconomic variables. So the guidance document works as a step approach
with 7 different steps, going through identifying what are the goals of the restoration activities, in which context we are in, and also identifying which barriers or disturbances we have in our land. After we identify the constraints, what are our priorities and which data we have available, and at the end we select the indicators that are relevant for our activities, and optionally we have also the creation of restoration index. So just going to the why restoration, which is identifying our goals, we have 4 different entry points in the guidance document, which are the restoration goals, biophysical and socioeconomic factors, ecosystem goods and services, and United Nations conventions. So for example, if we go through the path of restoration goals, we will have what WRI have called the restoration wheel, where we can identify in the outer wheel the themes. In the inner wheels, we have the sub-themes, and then we have in the central part the land use and the barriers to sustainability that will be measured anyway for all of the projects. So then from here, we can select what are the most relevant sub-themes for our project. Which one of the advantages of this visual wheel is just to make sure that we are having an holistic approach in our restoration activities. So once we have selected the sub-themes, we would have a list of indicators to measure those themes, and also specific metrics that we can use to measure them. This is only one example of the menu of the indicators. This would have been filtered depending on the sub-themes that are relevant to our project. And then the metrics are also just orientative, are examples depending on the availability of data and depending on our resources to measure them. For example, just if we had chosen for, the path of the UN conventions, we would have the same type of themes and sub-themes, but still a very slightly different list of indicators aligning with the different SDGs, Aichi, and LDN indicator frameworks. So that would be like mainly what the guidance is about. And now, as next steps, we are now working on transforming this decision-making tool into a web mobile app, just to get an automatic selection of the indicators depending on our goals and our barriers. And then also the app would allow us to track the progress, having comparisons between the most recent measurements and the previous ones. So this is just one kind of a mock-up that we are developing. Still, we have to work on the functioning and the visual identity, but we would have one screen for each of those questions that we were addressing before. What are the objectives of our restoration project? What are the disturbances that we have in our land? What that data we have available? And then we will end having a list of indicators that are relevant to be measured, and the tracking progress to see how it has been changing over the years. And with that, I finish. Thank you.
Thanks, Carolina. Now to a final presentation. Sorry, there's a very interesting topic. So too many presentations. But Yoshihiko and Khalil to a final presentation, and then we can have some nice discussion. Please.
All right, great. Thank you very much for all the presenters for each of the very interesting, informative presentations. I think they have all contributed to our outlining some of the key activities of the forestry department here at FAO. It's working on the restoration and restoration front, and all extremely timely as we move into the new UN decade of ecosystem restoration which was described by Mette and Julien before. So both Khalil and I are working on the Japan-funded project, and we are aiming to support 4 selected pilot countries, which are Uganda, Kenya, Cambodia, Myanmar, in their assessment, monitoring, and reporting of restoration activities in the coming 2 years. So which will be, of course, building on Jeff's work as well as some CEPAL functionality. So now our collaboration with ETH and with Jean-Francois in particular has been extremely valuable for our team and our work. So we sit in a privileged position at FAO as we are able to work closely with countries and as they are set to mobilize action and begin to reach their restoration targets in many goals they have pledged. Restoration layer on biophysical potential Jeff developed is one element we are already able to give them access to, and it will be integrated into CEPAL platform as Rennie already described. But our next step of collaboration will attempt to provide countries with increased information to be able to make some informed decisions about where restoration may be a good idea by incorporating additional elements beyond the biophysical potential. Now I'd like to hand over to Khalil to explain more details about our plans.
I'm just going to stay where I am and assume that that microphone will pick that up. Do you want to switch? Okay. Yeah, keeping our eye on time, I'll try to be very brief. But yes, as Yoshihiko mentioned, we have benefited greatly from the collaboration with ETH, but it is now our responsibility when taking the data to the countries to make sure that we do go a step further. And Jean-Francois did mention that we will be now attempting over the next year to try to provide them with the layer, but then also work collaboratively in these 4 countries to see what data is most important to them. So in the process of the creation of the global restoration map, taking out the crop areas was done with global level data sets. So if the countries have more refined data, geospatial data, if they have specific areas of interest as well that they would like to utilize, the process in 2020 will be working with them to try to refine and really hone in on specific interests that they have. And that could align with their national priorities, whether that's biodiversity or carbon sequestration, et cetera. So on the left-hand side there, that's really what our main goal for 2020 is with this project, is going through that exercise, as well as helping them utilize CEPAL in a more integrated way with the 2 monitoring, or the multiple monitoring platforms that Remy and Yelena have also been working on. So those are really our main areas. And then let's say our white papers on the other areas, we'd also like to maybe move into. Jean-Francois also mentioned the idea of biodiversity, or the idea of helping countries really on the assessment side, so not on the monitoring side, but helping them assess where and what they'd like to restore in a more specific and clear manner, but by allowing them to model potentially what their stable states and end states of forests would be, and then making decisions, again, aligning with their national priorities. So that's the biodiversity angle. One thing that's come up multiple times in-house as well as by donors is there seems to be a large gap in the socioeconomics when it comes to restoration. And this is a big area. I will say, again, it's still in the incubation stage of how we would actually implement this, but we have had a few meetings with colleagues in-house and with Marco Boscolo as well, and potentially using our 4 countries as case studies to maybe do retrospective or prospective studies to try to identify what the drivers are and see how we could integrate that into into an assessment tool. We know with restoration, when you're on the restoration transect, let's say, or along the way to restoring an ecosystem, if you don't help countries align to markets or to potentially to where socioeconomics could be addressed, you're not really addressing the driver. And then at the end of the restoration intervention, you're right back at the beginning where you have degradation occurring again. So the reason there's a gap is because it's a very hard thing to pinpoint. Recognizing that, we do think it'd be a worthwhile endeavor to try to move into do some research on that and other components such as forest tenure and other sociological aspects. Really, we're intending that all of this work that we'll do in 2020 and the work that's already been done ends up in a forestry working paper that really will end up being a guide, a user guide for countries. So I don't think the restoration paper needs any more sort of promotion. I think it's got a lot of that, but really it's about changing the audience. So saying, well, how can we actually now utilize that data in a meaningful way? So that would likely result in a working paper and a few new CEPAL modules to help countries better target their restoration activities. Yeah, with that, I'll say thank you and turn it back to Julian to help us have some questions at least there.
Okay, thanks so much, everybody. That was a bit of a marathon, sorry, but I think it was great hearing from the scientific community. Particularly, I was excited about hearing the future work on agriculture and land use. And thanks, Tom Crowther, for joining online. But please, now we have about, well, not much time, but it would be great to have some questions. And I really, we have a lot of people here working in different parts of the forestry department and colleagues from CB. So please ask away. Yes, please. The floor's open. Inga.
Maybe I have a remark. So thanks all for all these presentations. So I can see we will have a great range of tools for the monitoring coming from FAO. Maybe it would be good to know, or at least all the audiences. So to me, it's not clear if we target really governments with the tool like Carolina. Is this more for just landowners? It would be good to see how these are interlinked, because I think it's great that we have all these tools, but to see also how the impact will be having all these tools. Great.
Yeah, please, the floor is open to responses. Carolina?
The comment, because of course it's for more forest practitioners, so people carrying out restoration activities, but then also with the options of the indicators that are also aligned with the LDN and the Aichi, they're also meant to scale up at the country level.
And as you know, Inga, I think our main target is the governments, the people with the mandate for land management. But yeah, I think increasingly we're moving to non-government, and I think globally there's a push in parallel, like government and non-government, for transparency reasons.
I think it could be great also in the private sector. That's the whole deal. And linked to what Tom was saying, that more and more they want to look into also what's the financial. Interesting to you.
Yeah, please. Another question. Oh, Remy.
If there's no question, maybe I can go back to the technical. I've been wanting to ask this to you, Jeff. You've been, because you used the 10% threshold in the GFC to assess existing tree cover, right? You used the 10% threshold to the tree cover that you subtracted from the potential, the existing tree cover. Okay, you didn't use any threshold. In the supplementary, we did the exercise with like what could be restored in terms of forest, and that's the 1,600 million hectare that you have, and that's with the 10% threshold. But like the whole communication and the whole like carbon equivalent, etc., was done with like exactly if it's 1%, it's 1%, if it's 5%, it's 5%. It still holds. So my point is that we know from equally from Anson's team that anything up to 25% in their own product is really like we have a lot of uncertainties that it's actually tree cover. So a lot of it is actually not tree. So I was wondering if you tried several thresholds, that maybe it's in the supplementary then. Did you try if you subtracted less than all of the, because I think anything up to 25 is actually not really trees in the GFC product. So maybe you could actually gain, we could be less conservative. We could be a little bolder even in the areas. Did you just check what it gives, if it gives a substantial change? So instead of taking all, like cutting off at 25%.
No, I didn't do the test, but I think that it could be super interesting to try to do it, and quite easy to do it actually. So I think it could be a nice follow-up to do.
Maybe it doesn't change that much, and then it doesn't have that much of an impact on the existing places that you subtract, and then we increase the size of where there's potential restoration and we don't restrain. So yeah, just do the calculations, probably easy for you guys to check.
But it's super easy to check, and I think it will be a super interesting follow-up. I think that we will have very different case scenario, because it's I think that what we observe in the tropics will be mainly the shift from zero to like a lot. But I think that what we observe in the savanna and drylands is like it's more like small change, subtle change, so that will like probably like be removed from the analysis. But I think that it will be anyway interesting to try to dig into a bit more into that. And clearly, I think that it will be nice also to benefit from like improved data that you might generate also through CPOL, like using the Planet data, using the Sentinel data in order to have better trick of a map to improve a bit, like because with those maps maybe you can, like with Planet definitely you can intercept like low tree cover quite well. So using those in order to know better what's happening in the savanna could be also a nice follow-up, I think.
I didn't present any of those, but at the moment the only algorithm we have for dense time series analysis is BFAST, but it's quite slow. It's taking a lot of time, and it's very heavy in terms of computing. And we're just testing and trying CCDC algorithm, which is entirely implemented in Earth Engine, and it's doing an amazing job at also not just checking the changes, but checking the transitions between different land covers, and doing something similar using the collectors database for either the drylands, or could help us train global land cover models and then have explicit land transitions. So yeah, definitely things to talk about.
Oh, this is exciting. I think we should capture this in as we move from the 1 kilometer pixels to the higher resolution or the smaller pixel size for the country application. We can test some of these tweaks. Yeah. Thanks so much. Please.
Yes, comment and a question for under the Restoration Initiative program we are implementing with IUCN, UN Environment. Kenya is one of the countries. I want to ask, how easy is it now to get this global restoration map available for the country? We have to do the whole data analysis again, or can we just extrapolate? And is it a fast process? Because they are now Kenya is developing a first landscape restoration action plan, which will be quite useful to have this data. And comment, IUCN is working on the new analysis of restoration potential biodiversity for flagship species to see where the hotspots are for restoration and which species should be used for certain flagship species. Are you linking up with that maybe for biodiversity potential?
I think it's available in several places, the map, but yeah, please, Jeff.
Yeah. So yeah, it's weird. Okay, I will talk in the mic. Or right. So yeah, no, the map is available. Like you can find it on the CrowdLab website just for visualization, but it's also there's also a link on an ETH webpage where you can really download like the raster, so you can like work directly with it at the country level. The only thing that I want to underline here again is that you can download it, you can use it, but the map has been developed and validated at global scale. So it could be nice when you work at the country level to have like other ways to assess the quality of the map. Then for biodiversity, I think that I brushed that idea with Tom about when you make a list of species that could be suited to be restored in a given place, it could be nice to associate like the IUCN categories, so that we know that, for example, if we could be also effective by restoring in terms of biodiversity conservation. I think that it's there's definitely here like a mutual interest that we can develop with IUCN to make restoration more effective.
Exactly. Yeah. And Kenya is one of the pilot countries for Japan projects, so we'll be recalibrating the model, I think, and making it more useful for the country, and also then Kenya can intersect it with all their other land use layers, which I'm sure. So that's the next step that we'll be undertaking. More questions? We have a number of colleagues from CB here. Please, Danilo, Alfonso, ideas. Danilo was one of the co-authors of the paper. Okay. Oh, welcome. But Marieke?
Yeah, just one more other question, because there's other studies that we've seen before on the restoration potential, like WRI. So I think, what your approach is very interesting and nice, to do this R modeling based on the protected areas. But my question is, like, you, as the means of extrapolating this information, you're using the same underlying principles, no? It's like the soil maps and the climate maps, which is like the same maps that also these previous studies are based on. Like, how good are those, and how much do you think that affects And then maybe another question also, because like since you said you're looking at also soil samples over the world, is there also like an intention to improve some of these maps or?
Okay, so I will start with the second part and then we go with the first part. So yeah, so the intention is to, a bit like Anson, is to try to, as much as we can, improve the map that we created with using better data sets, either better climate data set, either better land cover, land use data set to do the subtraction. We will release like version 1.1, version 1.2 of the map. So as much as we can improve it, we will do it, and we intend, like, I don't know if it will be once a year or twice a year, or it will be a lot in the beginning and then it will a bit change with time. But we will release like improved version of the map using like the same methods but with better input data sets. Then I think that the big difference with existing product is that like a lot of existing product were using existing climate data, but like in order to define like big envelope and like with that, where you can do like, you can put dense forest here, you can put open forest there, and it was not really like a model that was built on observed data set trained really to link like a given amount of trees to a given set of combination of climate data. It was a bit more like a mix between using those climate data to define those envelope and a mix of expert-based knowledge, which were behind the WRI Atlas. So it's a bit like, clearly it's, I think that this work from the WRI was super important because it was the first one trying to really think about that potential. So clearly it was inspiring us a lot in our work. But I think that we tried with our paper to move from an expert-based approach with big envelope and not really spatial explicit, like, because you had like 3 categories, to a more like data-driven approach, fully replicable, fully quantitative, and which more like subtle change in terms of tree cover. So that's a bit the difference. Yeah, but Tom will generate a new soil map for the moment, and so this is like he's, from what I understood, he's applying the same approach using protected areas, and in order to have like the most intact soil as possible, and then to try to understand how the carbon varies in intact soil, and then to extrapolate based on those variables in the rest of the world. And definitely also, I think that, so we are part, Tom and I, of a network which is called the Global Forest Biodiversity Initiative, and he also now started the equivalent for soil. And I think that the idea here is to try to gather existing soil data everywhere around the world, and like the more they will get data, the better the map they will produce will be. And I can also imagine that they will do updates of those maps as well. It's also one thing about like using those protected areas was a bit like one of the key factor behind this paper. But we can also in the future, I think, try to think a bit improving that, because protected areas present 2 disadvantages. That first of all, most of them are quite degraded. So not most of them, but a third of them are quite degraded. So we're using them as an example of natural ecosystem. It's a bit actually underestimating what we could have. And also protected areas are located into areas of poor interest. So with lower interest, like you have a lot of areas where you could have huge forests which are currently occupied by croplands, and definitely, so by using those areas of poor interest, we are also a bit underestimating what we could have. So
Maria?
On the soil information, thanks for getting it to that. Yeah, I'm working here on peatlands, as you may know, but I'm wondering if there's anyone from CBL here. Also, it's our division on land and water, because they are currently working, of course, updating the soil organic carbon map, which is only on the top 30 centimeters with the country inputs, and then some scientific, let's say, review of that. But then the new product under the development is even more challenging, is the mitigation potential of soil organic carbon. And these are with the country data and often institutions from different key agencies. So that would be something quite interesting for you to combine the data from that source. Thank you.
No, definitely the more the data, the better, I think, for us in general. So definitely, I think that I need to put you probably in contact with Tom so that you can discuss a bit further about it. One thing though is I think that Tom is also like looking a bit into more deeper SOC. So definitely like having more information about the first 30 centimeters is great, but I think that he's also looking a bit into what you can reach like in total, like even further than 1 meter. But still, I think there is clearly there will be a huge interest from Tom on that side.
Please, another Ben, please.
Just one more question. Tom was mentioning, and that's very, very interesting, that they will start integrating the croplands and agricultural lands into the whole modeling. How would it be possible then to look at the trade-offs in terms of, like, for example, land degradation neutrality targets that countries are setting or have set, to see how restoration and these trade-offs can be managed, where the best position will be for actually forestry cover improvement and then other parts for agricultural land? Would that be possible?
That's a good question. The thing, I don't know exactly. I think that this will need like experimental or like ground-based data. Like we need, because what we are able to say is that in sub croplands we know how much more trees you can have, but we don't know exactly how will that impact the yield of each given culture. Like we have an example of a colleague of ETH that worked with cocoa, like Tom said, where it was like an experimental design, and it was like asked by the company, I think, to where they had like cocoa under different tree cover, so we could assess basically the link between the yield and the tree cover. But you don't have that, I think, for all the crop that you can have with trees and in agroforestry. So I think that this needs to be tested basically. So you have for most of the crop, you need to develop like a test on the field to get a bit of the information about the yields and the relationship with the tree cover. For the moment, what we know is that like for each given pixel in croplands, we know like what's the potential tree cover. So we know where agroforestry could be done, but we don't know exactly for each culture, like if it would be better to have 10, 30 or 40. But definitely taking as an example what has been developed in ETH with cocoa, I think that we can apply this to other type of culture.
It's very cool. We actually have a number of people online, so please maybe write if you have any questions for decentralized colleagues. But we're over time, but if there's any more burning questions, maybe we can break for lunch, and thank everybody, the guests and the presenters for